Hi, my name is Jad Omari. Come take a walk with me. My project focuses on how these little eggshells right here can help provide millions of people with clean drinking water. But what's stopping people from having clean water in the first place? Acid mine drainage. Acid mine drainage occurs when leftover abandoned mines leave sulfide-rich minerals to be exposed to the air and to water. The sulfur in these minerals then becomes oxidized and turns into sulfuric acid. This sulfuric acid leaches into our water sources, destroys ecosystems, and the people who need that water to survive. But what can we actually do about it? This shard right here of eggshells is made up of 99% calcium carbonate, the exact base that we need to refute the sulfuric acid that is leaching into water sources and corrupting pure water for millions of people a year. Hey, let's take a look at how the chemistry behind this all works out. To begin, acid mine drainage occurs when pyrite is oxidized and leaves two free-flowing hydrogen ions. These hydrogen ions will then lower the pH of the entire system. This low pH can eat at heavy metals and make them release into the system. What calcium carbonate can do is that it can trap these free-flowing hydrogen ions and turn them into water and carbon dioxide, while at the same time trapping out the sulfur by turning it into a solid. But what makes calcium carbonate such an amazing candidate for this job is the fact that its carbonate-bicarbonate system can create a buffer. Well, calcium carbonate is what we call a weak base. And because of this, it can create this buffer that can stop the pH from shooting all the way up at once and keep it controlled in an environment where safety and security is key. And then more than just this, when the pH increases and it interacts with the calcium carbonate found in the eggshells, these free-flowing heavy metals will then precipitate out of the river for locals to clean up and for us to do our parts. But how do we turn all of this chemistry into reality? I've chosen to create eggshell tablets, each of which with a different organic binder. I have tablets A through D. We have starch, aloe vera, fig extract, and cactus extract. In composition, 4.5 grams are made of eggshells and 0.5 grams are made of each of their own respective organic binder. Each of these can neutralize purely 4.41 grams of pure sulfuric acid, or to put that in perspective, 5 entire liters of water. But how did we test this? Unfortunately, we weren't able to get our hands on real acid mine drainage sewage. That's something I want to work on in the future, going into college and furthering my career, getting real hands-on work. But we modeled it using a 0.0100 molarity solution of sulfuric acid and metal salts. The tests we ran for were pH versus time, final equilibrium pH, the rate of neutralization, and the precipitate formation. There needs to be an actual way for me to deliver my eggshells into affected areas. So I took to OpenSCAD. OpenSCAD allowed me to render 3D models with code. So I started creating eggshell carriers with 3 things in mind: durability, water retention, and manufacturability. All of these options have narrowed me down to 3 designs which can maximize the efficacy of my eggshells. My project focuses on taking something as discardable as an eggshell and turning it into something that we can use to help millions of people have clean water. I thank you so much for your consideration, and go crew!